Good morning, Dr. Scott and everyone. Today, I will be presenting my topic on heuristic construction using computational thinking in non-routine problem solving. In today's increasingly complex world, many real-life problems cannot be solved using simple formulas. Therefore, it is essential for us to develop strong problem-solving skills. In this presentation, I will be begin with explaining the concept of non-routine problems. Then, I will introduce a real-world problem, followed by demonstrating how computational thinking and heuristic strategies can be applied to solve it effectively. So, to begin with, non-routine mathematical problem solving refers to problems that do not have a direct formula or fixed steps. In other words, when we encounter such problems, we cannot immediately apply a familiar method. Instead, we need to think critically and explore different possible approaches. Furthermore, these problems require reasoning exploration and decision making. For instance, we may need to test several ideas before selecting the most suitable one. In addition, non-routine problems may have multiple valid solutions. This means that different approaches can lead to different, yet acceptable answers. Therefore, this type of problems plays an important role in developing deeper understanding and critical thinking skills. Besides, non-routine problems have several key characteristics. Firstly, there is no obvious or straightforward method to solve them. This makes them more challenging but also more interesting. Second, they require high-order thinking skills such as analyzing information, evaluating different options, and even creating new strategies. Thirdly, they are often based on real-world situations. For example, planning routes, managing resources, or solving practical issues. And last but not least, they require logical reasoning, where we must justify our decisions and explain why our solution makes sense. All these characteristics make non-routine problems very useful in developing problem-solving skills. And to better understand, let us compare routine and non-routine problems. Routine problems usually follow fixed steps. For instance, solving a quadratic equation using a formula. There is only one correct answer, and the process is repetitive. On the other hand, non-routine problems do not have fixed steps. We must think creatively and decide how to approach the problems. They may also have multiple possible answers, depending on strategy used. This comparison shows that non-routine problems require deeper understanding and are more suitable for developing real-world problem-solving skills. So now, I will introduce the problem that I have selected. A delivery writer needs to deliver parcels to 5 different locations, which is A, B, C, D, and E, starting from a warehouse. However, this is not a simple routing problem because there are several constraints. Each location has a specific time window, meaning the rider must arrive within a certain time. And the rider also has a limited fuel, so the total distance must be controlled. In addition, some roads are closed, so not all routes are available. Finally, the rider is carrying fragile items, so unnecessary movement or backtracking should be avoided. So the challenge is to find the best route that satisfies all the conditions. And this problem reflects the real life situations such as delivery service like Grab or logistic companies. These problems can clearly be classified as a non-routine problems. First, There's no direct formula or standard procedure that we can apply immediately. Unlike the routine problems, we cannot simply substitute values into an equation. Second, the problems involves multiple constraints that must be considered simultaneously. For example, we need to take into account times windows, field limitations, and road closures. These factors interact with one another, making the problems more complex. Moreover, there are many possible routes that the delivery writer can take. Each route may produce a different outcomes in terms of time and distance. Therefore, we must evaluate and compare different options carefully. In addition, the problem requires optimization. This means we are not just looking for a solution, but rather the best possible solution under given conditions. For these reasons, the problem reflects real-world decision-making situation, such as navigation system or logistic planning, where multiple factors must be balanced. To begin solving the problem, we apply decomposition. Decomposition involves breaking down a complex problem into smaller, more manageable components. Firstly, we identify all the delivery locations, namely A, B, C, D, and E, along with their respective time windows. Next, we analyze the distance between each pair of locations. This allows us to understand how far the rider needs to travel. After that, we examine the road conditions, specifically identifying which routes are available and which are blocked. Furthermore, we consider the fuel limitation, which restricts the total distance that can be traveled. Finally, we clearly define our objective, which is to find a route that minimizes distance whilst satisfying all constraints. By decomposing the problems in this way, we are able to focus on one aspect at a time rather than being overwhelmed by the entire problem at once. As a result, the problem becomes structured and easier to approach. And after decomposition, we proceed with pattern recognition. At this stage, we attempt to identify the patterns or trends that can guide our decision making. For instance, we observe that locations with earlier time windows should generally be prioritized. This helps us avoid late deliveries. In addition, we notice that efficient routes tend to involve visiting locations that are close to one another. This reduces unnecessary travel distance. Another important pattern is the avoidance of backtracking. In other words, we try not to revisit the same location or path multiple times, as this would waste both time and fuel. Furthermore, we may group location based on proximity or similar time constraint. This allows us to plan routes more efficiently. By recognizing these patterns, we can significantly narrow down the number of possible routes. Consequently, we are able to focus on the most promising solutions instead of considering every possible. Next, we apply abstraction. Abstraction involves focusing only on the most relevant information while ignoring unnecessary details. In this problem, the key factors include distance, time, windows, and road availability. These are the elements that directly influence our decision making. On the other hand, we intentionally ignore less important details such as weather conditions or minor traffic variations as they do not significantly affect the overall solution. By doing so, we simplify the problem and make it more manageable. In fact, abstraction allows us to represent the problems as a simplified model, such as a network or graph, where locations are points and distance are connections. Therefore, abstraction helps us concentrate on what truly matters, and avoid unnecessary complexity. Following that, we design an algorithm to guide our solution. An algorithm is essentially a step-by-step procedure that helps us solve the problem in a systematic way. To begin with, we start at the warehouse at a specific time. Next, we arrange the delivery location based on their earliest deadlines. This ensures that urgent deliveries are prioritized. Then, from the current position, we select the nearest location this that satisfies all constraints, including time and road availability. After visiting a location, we update the current time and fuel level accordingly. This process is repeated until all the deliveries have been completed. It is important to note that this approach follows a heuristic strategy, specifically a greedy method, where we make the best local decision at each step. Although this may not always produce the perfect solution, it is efficient and practical for real-world situations. Therefore, the algorithm provides a clear and structured pathway for solving the problem. Once we have generated the possible routes, we move on to logical reasoning and evaluation. Firstly, we eliminate any routes that violate the given constraints. For example, routes that arrive outside the time window or use closed routes must be discarded. Secondly, we remove routes that exceed the field limitation as they are not feasible. After filtering out invalid options, we compare the remaining routes based on several criteria, such as total distance, time efficiency, and the number of unnecessary movements. At this stage, logical reasoning plays a crucial role. We must justify why one route is better than another, rather than simply choosing randomly. For instance, even if one route is slightly shorter, it may not be suitable if it violates time constraints. Therefore, the final decision is based on a balance between multiple factors. This step demonstrates critical thinking as we evaluate and justify our solution carefully. At this point, we can clearly understand how the computational thinking supports the problem-solving process. To begin with, decomposition allows us to break down the problem into smaller parts, making it easier to manage. Next, pattern recognition helps us identify useful strategies and reduce the number of possible solutions. At the same time, abstraction enables us to focus only on relevant information, simplifying the problems. In addition, algorithms provide a clearly and systematic sequence of steps to follow. Finally, logical reasoning and evaluation allow us to compare different solutions and justify our final choice. When all these components are combined, computational thinking transforms a complex problem into structure and logical process. Therefore, it plays a vital role in solving non-routine problems effectively. From this problem, we can derive several important insights. First, real-world problems are often complex and involve multiple constraints that must be considered simultaneously. Second, there is rarely a single perfect solution. Instead, we aim to find the most efficient and practical solution. Moreover, heuristic methods are particularly useful in such situations, as they allow us to make good decisions within a reasonable amount of time. In addition, this approach reflects how real-world systems, such as navigation apps, operate by simultaneously evaluating and selecting the best possible option. Therefore, these problems highlights the importance of flexible thinking and adaptability in problem solving. In reflection, The heuristic approach has proven to be highly effective in simplifying a complex problem. It allows us to handle multiple constraints in a structured and organized manner. Furthermore, it improves the decision making by providing a clearly framework for evaluating different options. However, it is also important to recognize its limitations. In particular, heuristic methods do not always guarantee the optimal solution. Instead, they provide solutions that are good enough and practical. Therefore, while heuristics are useful, they should be applied with an understanding of their strengths and limitations. This balanced perspective is essential for real-world problem solving. Finally, let us examine a comparison between two possible routes. On the one hand, the first route may appear shorter in terms of distance. However, upon closer analysis, we find that it violates certain time constraints, resulting in late deliveries. On the other hand, the second route satisfies all the given constraints, including time windows, route availability, and fuel limitations. Although it may not be the shortest route, it is more efficient overall because it successfully completes all deliveries within the required conditions. Therefore, the second route is selected as the better opinion. This example clearly demonstrates the importance of evaluation and justification in problem solving. It also highlights that the best solution is not always the shortest, but rather the one that meets all requirements effectively. In conclusion, non-routine problems require higher order thinking, creativity, and careful decision making, as they do not have fixed procedures or direct formulas. Throughout this presentation, we have seen how computational thinking plays a crucial role in addressing such complex problems. In particularly, decomposition helps to break down the problem into manageable parts, while pattern recognition allows us to identify useful strategy. At the same time, abstraction enables us to focus on the most relevant information, and algorithms provide a clearly and systematic approach to solving the problem. Furthermore, logical reasoning and evaluation are essential in comparing different possible solutions and justifying the most appropriate choice. In addition, the use of heuristic strategies allow us to find efficient and practical solutions, especially in situations where an exact or optimal solution may not be easily achievable. Overall, this approach highlights that real-world problems are often complex and involve multiple constraints. Therefore, it is important to adopt a structured and flexible way of thinking in order to solve them effectively. So, to conclude, computational thinking and heuristic methods work together to support meaningfully systematic and efficient problem solving in real life contexts.